again in the ACT series. Okay, today we are going to talk about similar triangles. Okay, what are the rules for this section? First of all, before I start solving the question, let's remember, what does it mean, similarity? Okay, so similar triangles, if I have two triangles, triangle 1, triangle 2, this is A, B, C, D, E, F. If I say triangle A, B, C, the similarity sign is this way written, not like congruence. We'll see that in chapter 10. Okay, it's similar to D, E, F. So in this case, since they are similar, I have to say now the ratios, which is AB over DE is equal to AB over DE is equal to BC equal to BC divide EF is equal to AC divided by DF. Okay? This is okay. And at the same time, the angles are congruent here. The sides, they are not congruent, they are similar, so the ratio works here. So A congruent with D, B congruent with E, C congruent with the angles, I mean. Okay, just remember those rules. If they are similar, how can I prove that they are similar? There are three rules. A postulate, if we find two angles, which are similar, like let's say angle A is equal to angle D and angle B is equal to angle E. In this case, we say that angle A congruent with D, B with E, we say AA postulate. So angle postulate. Okay, this is the first one. The second one, if we say that the sides are congruent, similar, let's say this is 10, 5, 6, 3, 8, 4. Let's say 10 divide 5, 2, 8 divide 4, 2, 6 divide 3, 2. In this case, the ratios are equal. So we say that both triangles are similar because of what? Side, side, side. So the first one, AA postulate, which is angle. The second one with side, side. The third one now is, if we say this is 30, this is 30. So the ratio is 10 divide 5, 2, 6 divide 3, 2. And the angle is there. So the third postulate, which is equal to, it is side, angle, side. Two sides ratio, they have the same ratio and the angle between them. So those are the rules for similarity. Remember that. So let's start solving the question. Question 1. Complete the similarity statement. Triangle SRQ is congruent with which one? SRQ with which one? Check. SRQ. Okay? If I can see here, the ratio, which is like 15 divide 10, because this is the hypotenuse, this is the hypotenuse. So if I say 15 divide 10 is equal to 1.5. Okay, and 9 divide 8 or 6, what do you think? So let's check. If we say 9 divide 6, that's going to be 1.5. Oh, good. And 12 divide 8 also is equal to how much? 12 divide 8 is equal to 1.5. So the ratios are clear now to me. It is the same, so they are similar. So I can say that SRQ is congruent with what? So far it's JKL. So the choice is D, triangle JKL, based on the sides that I divide. Of course, with respect also to the angle. Okay? We can say the ratio and we can say also the angle. So L, of course, comes with what? With Q. So it should be L and here to be Q. Okay, great. This is the end of question 1. See you in question 2. Which postulate, or theorem Okay, lets you conclude that triangle ACP is congruent with the triangle FED. ACP with what? FED. So, of course, if we say that 60 divided 24 is equal to 30 divided 12, I'm not asking you to calculate if it's the ratio the same, because we are saying that it is they are similar. Okay, so at the same time we have C side, and there is an angle. Of course, it's really clear that it is side, angle, side. Okay, this is the question done for question 2. Let's go for question 3. Okay guys, here we have question 3. Let's check the drawing. See, okay, this is J, X, K, Y, and Z. Okay, fine. We have 90 here. So J, X, K, Y, and Z. Please draw it. Okay, before I start. So the question in the diagram. Okay, above line JX. Line JX is parallel to line XY. So those lines are what? Are parallel. Okay, fine. So if JX measures 16, okay, JX measures 16, this is 16, okay, and XY, and and JX, okay, JX measures 16, yes, and KY measures 8. KY measures 8, yes, this is 8. Fine. So in this case, okay, we have 8, okay, and the area of the triangles JXY, okay, the area of the triangle JXY, what is it there? Sorry, JXZ, I'm really sorry. JXZ is equal to 80. Fine. So the whole triangle is equal to 80. Let's check how we can solve this. Okay. So the whole area of triangle JXZ is equal to 80. So half times base times height is equal to 80. So what's the base? We have 16. Half times 16 times h is equal to 80. Right? So which means half times 16, 8h is equal to 80. In this case, h is equal to how much? 10, which is the height. So this is totally is equal to how much? 10. Okay? So why I have done this? The question is still asking you, okay, what is the length of the segment XY? The length of the segment XY. So this is the first step. Okay, now I have, this is the total 10. Now I have two triangles, the smallest one and the other one here. Can you see? 1 second. Okay. JXZ. This is JXZ. Okay, and the small one is KXZ. Okay, KXZ. Fine. So JX is equal to 16, I know that. And XZ is equal to 10 based on the area of the triangle that we gave here. So this is the whole 10. Okay. KX is equal to how much? Is equal to 8. And XZ, I don't know. Let's go, it's X. So the value of X, that's going to be, they are similar. So based, why they are similar, mister? Because it's an angle postulate. So this is the first angle, 90, 90. And this angle, which is Z, is common for both triangles. So in this case, check. So we have two triangles here, as you can see. Okay, now we can say 16 over 8 is equal to 10 over X. 16 over 8 is equal to how much? 2 is equal to 10 over X. Okay, then in this case, X is equal to 10 over 2, and that is equal to how much? 5. So, if this part is equal to 5, then the segment that they want XY is equal also to what? to 5. So my answer will be here, guys, is what? Equal to 4. Okay, this is the end of question 3. Okay, see you in question 4. Okay, guys, question 4. So, by the way, this is part of the solution. Just to save time, I just wrote them. I will explain now. In the figure above, okay, triangles ABC is similar to triangles XYZ. The question said me that they are similar. So, if side XZ measures 10, this is 10. Okay, what is the area of this triangle? So in this case, if they are similar, it means they have the same ratio. If this is 15 to 10, which means that divide by 1.5, which is equal to 10. Then can I get this side and this side? Yes, of course. So 9 divided by 1.5 gives me what? 6. 12 divided by 1.5, it gives me what? 8. So what's the area of this? This is the base and this is the height. So in this case, the area is equal to half times 6 times 8, which means how much? 24. That's the answer, which is 24. Okay? Thank you for watching. Last question now. Okay, guys. Hi. Question 5. Now, I have this triangle, as you can see here. A, B, E, C, D. And in the triangle above, line segment BC measures 2. Okay, this is 2. Fine. And the line segment CD measures 8. This is 8. Okay. And after that, if the area of the triangle ABD is 25, ABD is 25, so the area is equal half times base times height, which is equal to 25. We'll come back to that. What is the length of the segment EC? I want this is EC. Okay, fine. First of all, if I want to get this side, I need to get this side. So I have the area, which is half times base times height. It's half times, I don't have the base, but I have the height, which is equal to 10, is equal to 25. It means 5b is equal to 25, b is equal to 5, which means the base, so this is equal to 5, right? So what's the size of EC? Okay, what's the size of EC? Let's check now. Now I can say that there are two triangles. The first one, which is as you can see here, okay, that's ABD, and this is 5, this is 10, and there's another triangle, smaller one, okay, don't look this, it's not scale drawing, okay, so which is ECD, EC, and here we got D, fine, okay, now I have CD, which is equal to 8, great, fine, and this is here what? X. So if I want to get EC, that's so far, we can say it's 10 over 8 is equal to 5 over X, right? Cross multiplication, okay, which means 10X is equal to 40, means X is equal to 4. So the size of EC is equal to what, guys? 4, okay? I know it's like, now I'm getting deep in triangles, but this is like similar triangles, and we need to understand triangles more. See you inshallah next time with triangles congruence, okay, and bye bye.